Okay, geometry. Last week we finished up chapter 9, circles, and then what I'm going to do first before we jump into chapter 10 is just kind of show you what these next couple weeks is going to look like. I've had a couple people ask, what we're doing or when we stop. The high school teachers were told that our last day of school is May 13th, but we're supposed to be done with you guys Friday, May 8th. So our last day of online learning, yay, will be in 2 weeks. So that Friday. So we just finished up chapter 9. So we've got all this week. We've got all next week. So 5 days here, 5 days here. So 10 days left, and that is it. So this is what I kind of have blocked out for you guys. We're going to go through chapter 10, which is formulas for area. So areas of triangles, rectangles, parallelograms, kites, rhombuses, all those good things are going to be in 10.1 through 10.6. Then we're going to do a chapter 10 review. You're not going to be tested over chapter 10, but then we will do a final review, which is kind of like the big review packet that I give you guys before semester tests. It's like 50 questions, and we'll go through that over 3 days, just kind of like normal, before we would do semester test. But the good thing is you guys will not have a semester test. It was kind of decided by Mr. Moore and by the rest of the teachers that semester tests, we wouldn't do this, um, you know, at the end of the school year. So no semester tests. So you're done testing. You will have a chapter 10 review in there. But the rest of these will otherwise be videos, and I will just embed questions into those videos. So this is kind of what your next 2 weeks are going to look like, and we are so close to the end. Okay, so jumping into chapter 10, 10.1 is what we're going to go through today, which is areas of parallelograms and triangles. Okay, and before we get to that, I want to talk about, at the top here, add this to your notes, the area of a rectangle, because that is one that you should know already. So if I have a rectangle here that is like, let's say 5 units and 3 units, okay? The area, you would just take 5 times 3, and that would be 15. So the area of a rectangle is base times height. That's the area of a rectangle, okay? Now, when we're doing a parallelogram, okay, parallelograms are ones that are kind of slanted. A rectangle is technically a parallelogram, okay? But all parallelograms, regardless of whether they're slanted or at right angles like what this rectangle is, the area, no matter what, is going to be base times height, okay? And the reason for that is, okay, if this is the base, the length of that parallelogram, and this is the height, what I can do is I can take this chunk, this little triangular piece over here, and I can lump him over to the side and add him onto the end here, and he will make a rectangle where the bottom is the base and this vertical distance is the height, okay? So I can take that parallelogram and transform him into a rectangular looking thing. And we already know that the area of a rectangle is base times height. So that's kind of exciting. No new formula there to memorize, okay? But what you need to make sure of is that when they give you the dimensions of this parallelogram, the height is the vertical height. It has to be perpendicular to the base, okay, at a right angle to the base. They will a lot of times give you this height, which is the slanted height, and that's not the correct height that you're going to use, okay? So it has to be the vertical height this way, not the slanted height, okay? If they give you the slanted height, you have to find the vertical height. Like down here, they give me both of them. So technically this parallelogram is tilted or kind of like on its side. So if I turn him this way, I turn my paper this way, the base here will be the same as this base here. So the base will be 10 inches. The height is the vertical height, which is 3.5 inches. Okay, this 4 is not necessary. We do not need that information, okay, except to find the perimeter, which they're going to ask for also. So they ask for a perimeter, in which case we will need the 4. I'll put the 4 back in there, I guess, whatever. So each one of those sides will be 4 to find the perimeter, but then this 3.5 is what I'm going to use for the height, okay? So to find the perimeter, it says find the perimeter and area of this parallelogram ABCD. So to find perimeter first, I'm going to put a P here. Perimeter equals. I have these two sides are 4 and this top and bottom are 10s, okay? So I don't know how you add them together. This is how I add them together. I would take the 10s and add them together. That's 20. The 4s and add them together. That's 8. So 28. And that would be in inches. Okay, now perimeter is not squared. Area is the only thing that is squared. So this area I need to do in inches squared is what my label will be. Okay, and so area is base times height. base times height, and the base is going to be 10, and the height is going to be 3.5, okay? You should not need your calculator for that. 10 times 3.5, you move the decimal. 35 inches squared is what the area of that little parallelogram shape thing, okay? So if they turn it on its side, just be careful, make sure you figure out what your actual base is, okay? So example 2, area of this parallelogram, okay? They don't need perimeter, they just want area, so we need the base and the height. Okay, so I label out what we need, and then I fill in what we have. So according to this, the base, this bottom side along here is 15. So I know the base. The height, they give me that this is 8.5, but remember that is not the height. The height is this guy. Oh crap, how are we going to do that? They don't have height labeled. They just have it as h. So what we can do though is this is a right triangle, okay? And because they give me that this is 45 degrees in there, I can use SOHCAHTOA, going back a couple sections ago, I can use SOHCAHTOA to figure out what h is, okay? So to do that, 45 degrees is the angle that I'm looking at, okay? So h is that opposite hypotenuse adjacent. That one is going to be the opposite. And then the 8.5, the other piece that I have, is the hypotenuse. Okay, so I have opposite and hypotenuse. Okay, so out of SOHCAHTOA, SOHCAHTOA, which one of those uses opposite hypotenuse? That's going to be sine, opposite hypotenuse. So I'm going to take sine of 45 degrees equals opposite, which they call h, over hypotenuse, which is 8.5. And then to figure out and get h by itself, all I would need to do is multiply by 8.5. Okay, so that's gone there. So 8.5 times sine of 45. Okay, you want to make sure that your calculator's in degrees. So if you're getting a different answer than me, it's probably because you're in radians. So I want to do this. I want to do 8.5 sine of 45. 8.5 times sine 45. I got 6. So h is equal to 6.01. So that's going to be my height, 6.01. And then I'm just going to take that number and multiply him by 15, because that's going to be my base and my height. So 2, not 9.2, 90.2 millimeters. And since we're doing area, that is squared. Okay, so they might make it a little challenging to find the dimensions that you need, but it's just base times height the whole way through. Okay. All right, now moving on to triangles. You should know the area of a triangle, but if you don't, here is how the area of a triangle is explained, okay? So we know the area of a parallelogram, area of this guy was base times height, okay? Now, this guy, if I take him and I cut him in half, like this, like they've done over here, if I take this guy and cut him in half, and I look at like this piece or this piece, those are two separate triangles, okay? Like here, two separate triangles. So what I notice is that when I take the area of this parallelogram, the whole thing, that's base times height, but if I cut him in half, 1/2 base times height will give me the area of a triangle, because a triangle is half of a parallelogram, okay? Maybe I'll put that in here. Triangle equals 1/2 of a parallelogram. Okay, any triangle is 1/2 of a parallelogram. And again, you want to make sure that the base is truly your base and your height is perpendicular to that. Okay, so height is not going to be this slanted guy. Height is going to be this one. Okay, so 1/2 base times height. That one you should have memorized. Okay, and that's how they get this up here. 1/2 base times height, or sometimes they will write it as base times height divided by 2. They'll just put that 2 on the bottom, and that's a-okay too. However you want to think about that. Okay. So here they want us to do perimeter and area. Now perimeter, you're just adding together, and when you're doing perimeter of a triangle, you'll have 3 numbers to add together. So I'm going to put 3 blanks so that we have that ready to go. Area is 1/2 the base times the height. So I've got my formulas all ready to go, and here we go. Let's read the story. DeAndre needs enough mulch to cover the triangular garden shown and enough paving stones to border it. So the paving stones are those little kind of look like bricks going all the way around, okay? They can be circles or whatever you want it to be, but those are going all the way around. So the paving stones is going to be based on the perimeter. Paving stones, that's going to be my perimeter. And the mulch is going to be referring to area. So, A-R-E-A. Okay, so mulch is going to have to do with the area. The perimeter is going to have to do with paving stones. If 1 bag of mulch covers 12 square feet, I'm going to put that over here. 1 bag mulch equals 12 feet squared. 12 squared feet or 12 feet squared. And 1 paving stone, 1 stone equals 4 inches. Okay, how many bags of mulch and how many stones does he need to buy? Okay, so let's figure this out. We want to first do the perimeter, and they have all of our sides labeled for us. This side is 23, this side's 15, this side's 7. So 23 plus 15 plus 7. Okay, 23 plus 7 is 30, and 30 plus 15, try to do some of this in your head. 30 plus 15 is 45. So the perimeter is 45 feet. Okay, now, perimeter had to do with the paving stones. 1 stone is 4 inches, but I want to go 45 feet. So how many stones do I need to have? Well, first of all, I need to switch 45 to inches. Okay, so how do I go from 45 feet to however many inches? I'm going to multiply that guy by 12. Okay, so 45 times 12 is going to give me 540 inches is what I need to cover. Now, if 1 stone does 4 inches, how do I figure out how many stones that I need? Well, I'm going to take that 540 and I'm going to divide by 4, and that's going to tell me that I need 135 stones. Okay, so that answers that question, right? Now, the next one that we need to do is the area to figure out how much mulch we need, okay? So I need the base, 1/2 base. The base is going to be 7, just that little base right there. Base is 7. Height, now which one is the height? Is it 15 or is it 9? The height has to be that vertical height that's perpendicular to the base. So even though the 9 is out here to the side, because this is an obtuse triangle, that 9 is what my height is going to be. It's not 15. Okay, this one looks kind of funny because it's an obtuse triangle. This is an obtuse angle. But that's the dimension that I use. I use that 9. Okay, so 1/2 of 7 times 9. 7 times 9 is 63. 63, 1/2 of that, or 63 divided by 2. 6 divided by 2 is 3. 3 divided by 2 is 1 and 0.5, 31.5. Or you can do that on your calculator if you'd like, but try to do as much as you can without it, okay? So 31.5 square feet is what is going to, the area of that thing. Now, how many bags of mulch will I need? Well, 1 bag of mulch will cover 12 square feet. So how many bags do I need? If I take 31.5, and I divide that by 12, I get 2.625 bags. But if I walk into a store, they're not going to allow me to buy 2.625 bags, so I'm going to round that up to 3 bags is how many bags of mulch I'm going to buy. Okay, so that answers that question. All right, moving on. Example 4, use the height of a triangle the height of a triangle is 5 centimeters more than its base. 5 centimeters more than its base. So what we're going to do there, 5 centimeters more than its base, we're going to label the base as some value. They call it B. So the base here, that's labeled as B. And if the height is 5 more than that, then the height is going to be represented as B plus 5, just like they have here. I'll write it in there bigger. Okay, so the base, and this is 5 more than the base, so B plus 5. The area of the triangle is 52 square centimeters. Find its base and height. Okay, so what I want to do is figure out, so area is equal to 1/2 base times height. Okay, and then I'm going to plot my stuff in there. We know that the area is 52, so I'm going to plug that in. 1/2, the base is just labeled as B, and the height is labeled as B plus 5. Okay, so I'm going to plug those guys in. All right, now, let's see. What do I want to do? I'm going to do this. I'm going to multiply this guy by 2 to get that 1/2 to go away. Let's just get rid of the 2 to start with, or the 1/2 to start with. So 2 times 52 is 104. Now you wouldn't have had to do it this way, but that's okay. Let's just go ahead and get rid of the 1/2. And then this b, I can distribute him through. So I have b squared plus 5b is what he will look like. Okay, now this one's kind of a tricky one. B squared plus 5b, that's going to give me a trinomial, and from algebra, we know that we need to factor him down if he has, like this is kind of x squared plus x plus a number. So what I'm going to do is I'm going to put this 104 to this side, which means I need to subtract him over, so I'll have 0 here is equal to b squared plus 5b minus 104, okay? And then I need to think about, okay, what 2 numbers can I multiply to get 104, but when I add them, give me a positive 5, okay? And 104 is a big number, so I'm going to do off to the side over here. Okay, I know I can use 1 and 104, but that's not going to, adding those together is not going to give me 5. Let's see, 2 and 52, that's not going to work. 3, nope. 4 goes into 104, 26 times, 4 and 26, still not going to do it. Let's see, 104 divided by 8, 8 and 13. Aha, that's the combination that I want, 8 and 13. Okay, so what I'm going to do is I'm going to break this guy down into multiply to give me negative 104, add to give me positive 5. So it will have to be a positive 13 and then a negative 8. Okay, so here's the deal. When I set those equal to 0, b plus 13 equals 0, and b minus 8 equals 0. So if I subtract 13 over, b will be negative 13, and b will be positive 8. Okay, now problem with this and the way that this is written here, base is this length across the bottom of here. Can I have a negative length? No. So the only answer that I'm going to actually be able to use from this is that the base is going to be 8. Okay, so find the base. Now we need to find the height. Okay, so if the base is 8, the height is 5 more than that, right? The height of a triangle is 5 centimeters more than its base. So if the base is 8 centimeters, the height will be 13 centimeters. Okay, that's kind of a coincidence if this was negative 13 and the other answer is 13. Huh, that's kind of exciting. But anyway, so base height, just figure out what your labels are going to be, and then you can just plug into the formula to get those answers. All right, I'm going to go ahead and skip example 5 because I think you guys kind of get the idea. And that'll be it for 10-1.